Alright, I have these two vectors, both in the bracket form, and both of these are ket vectors, because as you can see from the arrow pointing to the right, and the fact that there is a straight line on the left. And then I have to find this in the product of these vectors. So how am I gonna do it? First of all, I have to find what is our bra of alpha is equals to. First of all, it's the transpose of alpha. So it's gonna be something like this. Don't worry about it. Transpose, and then the conjugate of a vector, which is written more quickly, just with this cross. Alright, so it's equals to transpose is 1, 2i, 3, and then complex conjugate is going to equals to negative 2i. And so I multiply this by my alpha. Alpha we said is equals to this value right here. So we get 1 times 1 plus negative 2i times 2i plus 3 times 3. So we get 1 plus 4 plus 9, which is equals to 14. And that is our first answer. Oops. Okay, I don't understand why it decides to give me a hexagon and I'm going a square. Okay, then the second one will be beta times beta in the product of the beta. In order to do this, we'll again have to find the transpose or the bra version of beta, which is equals to, but beta is equals to negative 1, 1, 1 I, so negative 1, 1 I, and then the complex conjugate, so negative in front of the I. So this times our beta, which is equals to this value over here. Equals to negative 1 times negative 1 plus 1 times 1 plus negative I times I. So first one we're going to get 1 plus 1 plus 1. So is equals to 3. Okay, again. Okay. And then the last one is the bra alpha times ket beta. So bra alpha we said is equals to this value right here. And then the ket beta is equal to this. So we're gonna have 1 times negative 1 plus negative 2i times 1 plus 3 times I. So we get negative 1 minus 2i plus 3i, which is equals to I minus 1. And that is my final answer for this problem right here. Now, one additional thing is that I can show that this calculation that I just did, which was the bra alpha times beta, is equals to the opposite conjugate. So it's equals to the bra beta, the alpha, and then the complex conjugate of this. So I'm sure I already have the answer for the first one. So I'm going to take the bra alpha. Bra alpha says equals to this. Duplicate. And then bring it down over here. And then the alpha, which said is equals to this value right here. Copy and paste. Then of course out of this we have to find the conjugate. So we're going to have negative 1, put this all in. Okay, negative 1 times 1 plus 1 times 2i minus I times 3. So always conjugate is equals to, so we're going to have negative 1 plus, oops, yeah, 2i minus 3i. Compass conjugated, so we get a -1 minus I, and in fact, if we find a conjugate of this, we're going to find that is equals to -1 plus I, or I minus 1, like we just proved. So our thing has been indeed proved. As you can see, we get the same answer on both sides. Okay.